Draft science video, yay. Okay, anyway, alright, so a couple of things on my mind. It's sort of related to magnetism, but I don't know if I'm going to actually get to magnetism. I want to talk more about the basic conflict between particle and ether, just the way people are using these terms, and just clarification. And it's based on these two people that I've been looking at their stuff. So there's this Kenneth, what's his name, Wheeler, who is the whatever, well, whatever that YouTube screen name is, the camera guy, and the magnetic camera guy, and the other guy, which is, I don't remember his name. Yeah, it doesn't really matter, right? Well, I guess I'll get to him first because he hasn't said anything lately. and you know, I'm sort of, you know, reading some of his articles. You know, he writes a lot of stuff without saying anything, which is sort of irritating. I'm sort of noticing. I'm really having a hard time understanding exactly what his counter theory is. But it's the Miles something or other, right? Miles, yeah, Miles something. Anyway, I did notice he hasn't published a new article since the 29th of September, which is way below his average. You know, it's you know, every now and then he takes a month off, but yeah, it's just kind of unusual that he hasn't published a new one. You know, just because I'm kind of curious if there's any before and after effect. Because I'm pretty sure he didn't read any of my stuff, but I'm just curious. But anyway, so let's just move on to the magnetic guy for now. And I'll just keep working on trying to figure out what the Miles guy is saying. I'm sort of figuring out what this guy's about, this Kenneth guy. So it's sort of Tesla based, I guess. That's the most famous propagator of it. So he has this online book, and you know, like the Miles guy, he spends an awful lot of time just talking about how everybody else is wrong, which is okay, an asshole and a jerk and a fuckhead and, you know, all the other. You know, it is a little bit excessive. I really don't see spending that much time going into all these, you know, this stuff about how other people are wrong and there's a conspiracy and it's evil. I think it's okay. I mean, I agree. There's a lot of religion in science, and you know, whatever the mechanism of religion is. I mean, it's, you know, religion is so obviously stupid, and yet people cling to it, and they do that for psychological reasons. And I think the same thing happens in a lot of these other fields, as people get attached to things. And I think his own attachment to Tesla is, you know, just another Jehovah kind of syndrome. I guess people pick their own savior, or whatever, however you want to look at this whole you know, heroic, inheroic thing or something, and maybe it's all based on, you know, how much they like or dislike somebody for, you know, based on their personal character or some other attribute. Can't say that some of that doesn't happen to me too. I can't say I'm not vulnerable to some of that. I mean, there was a time when I started buying into this propaganda. You know, there's a lot of talk about Edison being a jerk, but you know, the more I researched Edison's life, the more I found man seemed to have an awful lot of character. You know, you see pictures of somebody with, you know, Ford, you know, or other industrialists, and you sort of draw conclusions, and maybe that's not fair. And you know, Einstein, I might have started doubting, you know, Einstein. You know, when you find out that, you know, he abandoned his kid and did a lot of, he's kind of a creep. And you know, those little things start to add up in your head, and so then you end up starting to think certain ways, and so then you start building whatever you think on top of their thing, and then that ends up being, you know, you end up dependent almost on the premises of your predecessors. And I suppose that's a dangerous way to do anything, you know, is to personalize any of this stuff. Well, I didn't want to get into this conversation, but anyway, I mean, it's part of the conversation, I guess, is in the sense that you're, you know, why is science so difficult? Why is everything so difficult to have a rational conversation between human beings about why they think the way they think, instead of this idea that everybody has to be some sort of insincere bullshitter. And the fact that there are so many insincere bullshitters is part of the problem, I suppose. But I mean, people who generally want to just say, look, I believe this for reasons, not no reason. And the reasons aren't stupid reasons like Einstein was a shitty father. No, the reasons are something deeper than that. So anyway, so this guy is one of these, people who want to destroy the idea of a material universe. He calls it idiotic, and he had, all this rhetoric about how stupid it is to believe in a particle and all this, and it's like so excessive. And they're saying, well, get rid of that excessive nonsense, because there is lots of evidence for that. So there's no need to do all that crap. And somebody left a comment in one of my videos about the ether, and the trick is, is location. You can think of anything as, you can turn the ether into a thing or have it a nothing. It doesn't. The two don't. They're not incompatible ideas in a sense. So if I make a field of just pixels like this screen, it can be wavy and do all kinds of things. It can be a carrier for all that. So it can have pixels, and the pixels can carry motion. So they can be fixed pixels, but they carry motion, they carry identity. And their identity changes. It creates the effect of a transmission, a movement of this, blue goes from this pixel to the pixel next door. Now, did the blue travel there? Or did just this pixel, this one turn green and this one turned blue? I mean, you can think of it both ways. You can think the blue traveled here and the green traveled from somewhere else and got to that pixel. Or you can think that, yeah, they just changed. Well, what's the difference? Mechanically, it doesn't make any difference. At a point in time, this one was blue and this one was green. And that's all that really matters. It doesn't matter exactly whether blue jumped from where the green location is now to the blue location. It doesn't matter. So I'm just saying, as a practical fact, it doesn't matter whether you reduce it to a checkerboard or you just reduce it to checkers. So whether you're thinking about the board having a checker, a space having a checker on it, or if you just think about a checker having a space on it, having an identity, a location. What's the difference? I don't think there's any difference, practically. So, all right. So that's, I think fundamentally, see, the Kenneth guy is basically just saying there's no particles, and I just think that's a mistake, because I think then you just deny the real mover, the thing that's making things happen. And the problem with people who have an ether theory, or even a field theory, is they don't recognize that the field is moving, that the bits aren't static, none of them. There's no such thing as a thing that exists that's not changing, moving. And so that's where I'm saying that I think I've found the solution to the problem. If you create an ether that doesn't have any dynamic, then where did the movement come from? Where did everything come from? All this moving stuff. Where did it come from? So it has to be in the field itself, and that we're just condensates of the field, that we're just things that precipitate out of the field, and we're just recognizable now. We can see our movement. We can't see the movement in the field, but the movement's there, and the movement's inside of us. And it's just the fact that we are condensations, we are consolidations of specific movement, of a certain amount of directionality that's built into us as a whole, and then us as each little bit of us has its own identity in terms of a directional potential. Okay, directional potential. So I don't want to coin too many phrases. All right, so a key phrase he uses in this description, I mean a phrase I pulled out, not one that he thought was key, but one I pulled out as key, was he used the term ether pressure. And that's where I would say, look, just think about what you just said there. You know, when you start talking about a pressure in the ether, you've got to convert that into this idea that maybe this ether is a field of moving things that would create pressure. Moving bits in a you put moving things in a box and they'll create pressure instantaneously all by themselves. That's the nature of movement. So there's no, like I said, if I take a box full of little BBs that are bouncing around and I stick something in there, that thing I stick in there is going to feel the pressure. It's going to feel BBs hitting it from all directions all the time. Alright, so I think that is sort of a way of just recognizing that this idea of destroying the idea of particle because you want to go with field, the two aren't incompatible. If you just recognize that, yes, what has been identified as particles, electrons and protons and neutrons and all this kind of stuff, those aren't really particles, those are collections of particles. But that the particle, the ether, is this simpler thing, this BB, this bit. And, you know, that makes your field. You know, to think that it doesn't come from somewhere, then it's just a huge mistake. To say it comes from the thing itself without explaining that the thing itself is made out of this stuff that's moving. And that the movement's still happening outside of the stuff. This is just stuff you see, but the stuff happening is still happening all around it. And what you're seeing is what light is bouncing off of. So this is another thing where I think he makes a couple of simple mistakes. You know, from my perception, they're simple mistakes, in that he is often describing what you're seeing here as if the light is doing the thing you're seeing. And obviously the light's reflecting off the thing you're seeing. What you see is not light. You're seeing reflection off of a thing that's reflecting light. And it's that thing that's got this shape, not the light. The light isn't being forced to do this. The light's just reflecting off the thing that's doing that. Just like with the magnetic field, it's sort of a, it's like a reverse barometer in a sense. I mean, people see the field lines and they think the field lines are where the activity is. And ironically, it's where the field lines aren't is where the activity is. That's why we don't see something there, is because nothing can stay there, because the field is strong there, the pressure is strong there, and it's forcing things out of its place. It won't let them stay there. And so we're seeing where the stuff ends up because it can't stay where the real intensity is. So it's almost an opposite barometer of the real place where there's real action. Alright. And it's not really a real place. It's a place where the stuff will be pushed to because it'll have nowhere else to go. Because it has no velocity. It can't freely move. You know, it'd be interesting if they showed some of these things in zero gravity. But, you know, zero gravity isn't really zero gravity, so that's a catch there too. There's always catches. You know, anyway. I mean, it's zero gravity in the sense that you've compensated for gravity with an extra velocity. But in a sense, it's just extra velocity. It's not zero gravity. I guess for the purpose of relativistic motion, it's zero gravity. So that would be the important thing. So that's sort of one of the things I want to sort of broach into, is the fact that there is these three dimensions of direction. And it doesn't matter where you orient them. They're just that there's three opposites. You know, there's left, right, up, down, forward, back. So you have these three places where you can have opposites. You know, and it doesn't, like I said, it doesn't matter where you orient them. It doesn't matter which one you identify. You're just identifying the opposite, and there's a whole bunch of variance going from 0 to maximum, and then, you know, the opposite. And those dimensions are real. And significance. And so everything that's moving almost like light, being, you know, red, blue, yellow, or green, it's a mixture of those three dimensions. So if you have a velocity, your velocity is a mixture of vectors in those three directions. You're going a certain amount that way, and a certain amount that way, and a certain amount up, you know, in terms of, that's what it's really made out of, is your directionality is a composite of everything that's moving, and the end result is a direction. And so that's what I wanted to get to with, so there's two things I've been working on, is understanding the absorption of this gravity. So I'm arguing that gravity is basically, when I'm gravitationally attracted, what's happening is my matter is absorbing pressure coming down, and it's not allowing it to get down. It's not allowing it through me. It's slowing it down. It's absorbing it. It's changing my matter. And as a product of that, I gain velocity through this acceleration. So my directionality is changed. And so when you change directionality, you have to absorb a force. So you either have to apply a force, like a rocket applies a force, or a hand. I can push something or launch something. I'm applying a force. So for something to move, I either have to apply extra force, purely my hand moves in a vector, and this thing absorbs the vector, or I have to take it from the field. And that's what gravity's doing. Gravity is taking, absorbing directionality. I gain it. I now have velocity because I took it from the field. And by doing that, I'm not allowing it to go through me. So the thing below me is feeling an absence of force, pressure, and now it's going to gain velocity, or it's going to acquire acceleration towards me because it's going to have more stuff it's going to absorb going through it. And it ends up being inductive in the sense that as I get more, it gets less, I get more, it gets, and it just keeps feeding each other, in the sense that we both become more and more imbalanced. So the little imbalance starts, and then the thing just keeps going. And so to understand why or how the induction happens, you probably haven't followed all that, so I don't know if I want to try to explain it. Let's just take the broad field first. Okay, so I'll try to. So let's just say you have this field, and like I said, it's like the BB thing. And so you have directionality that, in essence, comes in equal proportions from all directions. But at any 1 minute, any 1 millisecond, any one frozen bit of time, it could have, you could get hit if you were sitting here by 3 arrows going this way, right? Now if you got hit by 3 arrows, you're sitting here going that way, yeah, in that they went through you, alright, and every time they go through you, what essentially happens is that the arrows you have are going to be changed to these arrows. So let's say, in the simplest form, as I've tried to describe, a material object is basically a consolidation of balance. So it's basically just it's having a vector in the 3 dimensions. Now see, I can only draw you 2, so you just add the other dimension and just say, okay, we understand there's still another dimension, which is this, you know, the 3rd dimension, and we're only playing with 2 just to make this somewhat comprehensible. But that there's a balance, there's an equal amount of each direction. Okay, so you can understand it in the box sense, in the sense that you have an arrow going this way, you have an arrow going this way, you have one going up, and you have one going down. And that's basically the creation of an orbit. Well, I did it backwards, but you understand. This one's going up, this one's going down. Anyway, you get the idea. It's just doing the circle thing, except it's a square, but it doesn't really matter. Alright, and so if I have this balance, and let's say I put that balance in this field. Now, you could argue that if it gets hit by three things going this way, then it's going to change these arrows, and so it's not going to have balance anymore. And obviously, I'm just using 4 arrows, so it's a distortion of the reality, but you'd end up with a funny shaped box, because now you have 3 arrows going this way, and maybe you only have 1 arrow left going this way, and that's not really a square orbit. But it doesn't matter in any one moment in time, is my argument. So let's say if I did absorb these 3 arrows, and so now my matter is defined by this configuration. It's only going to be that configuration for one moment, let's say a 1/10 of a second in a second. So for a 1/10 of a second, this is what I look like. The other 9 seconds, I look exactly the opposite, and I mean, I have my balance. Okay, so when you add up for the full 10 seconds, I'll come out balanced. So 1 second I could be doing this, and 1 second I'll be doing exactly the opposite. But that's any period of time. I can be in any state, but that I have an initial state, and that initial state is always going to be a prejudice state. So let's just say that this happened, and I absorbed these 3 arrows, and so now I'm an object moving this way. But what did I do? I took those 3 arrows from this field, right? Because I had a coincidental, just a circumstantial imbalance for a moment. Like you're flipping heads and tails, and you get 5 heads in a row. Well, statistically, you're going to get 3 or 2, or in some measure, you're going to get those 5 heads. You're going to get the 5 tails that you didn't get. They're going to show up as a probabilistic fact. So in a sense, you can understand that what happened here was I took direction in this way, but the field is now minus that direction. And this spot, this location, is due, essentially, by logic, probabilistically. It's going to happen. The other direction's going to show up, because the field is now minus these 3. So the field is going to rebalance, and this spot is going to get hit by 3 extra arrows going the opposite way. So eventually there's going to be a readjustment. It exists in the field itself. So in a sense, I've pulled directionality out of the field, but now the field is minus those arrows, and it's going to push those arrows back again. It's going to balance out. And so that's what makes this all kind of tricky, is in any 1 second, the thing can be in a condition that can't be its native condition, because it's taken something out of the field. It's a reflection of a field imbalance rather than its own imbalance. So when the thing is looking like this, proportion of it's going in one direction, it had to take it out of the field to get that way. So let's say I have a velocity. So now we'll just expand this. If you understand what I'm talking about, you'll understand this square can be turned into 100 arrows or 1,000 arrows. And that velocity in any one direction could be just having 1 in 1,000. So you have let's just make it easy for the sake of doing this. Let's say there's 500 arrows going this way and 500 arrows going this way. You could have 499 going down and only 501 going up. So now you have a velocity in this direction net. Your net velocity will be in this direction. And if you go into the field you'll just maintain that because the field's going to be balanced. So even if the field hits you with a bunch, and then it'll never, it'll always give you back what you brought to the field proportionally because it's always balanced. So the only way you can change this is if somehow you absorb something out of the field. So now you've changed your character, and now you're not moving anymore. Then the field will just perpetuate your non-moving. But for you to not move, the field has to give you a disproportional shove. It has to give you that one extra arrow, getting rid of the extra arrow you have. And so that's the nature of momentum and gravity and velocity and all this stuff, is just grabbing a disproportional amount of field, and at any one moment in time you may not be moving or you may be moving, but the only thing that matters is over time. There's some what fraction of a second, of a millisecond, of a tiny second. But I'm just saying whatever the clock speed of the universe is sort of irrelevant. But I'm just saying you can sort of understand that the balance is always, the field has a balance, and so no matter what I bring into the field, the balance of the field will allow me to retain what I have as a velocity, and it'll just stay that way because the field is going to, if I have one extra going this way, the field is only going to give me the same amount, and so inevitably I'm going to get back that arrow. I'm just going to keep getting it back, and I'm going to keep that in balance, whatever I have. And the only way that can change is something. The field can't do it, so it has to be another piece of matter. Some other piece of matter has to hit me with an imbalance in the opposite direction to stop my velocity, to create acceleration in the opposite direction. All right, you might have gotten that. But that's, so this goes back to what's the mechanism that allows this directionality to be filtered out of the system. And I guess what I'm arguing is the mechanism is the fact that the field has a field density. So you could argue that the field has an average distance between things, that would be a certain distance, d equals whatever, 10. Okay, but when they're in matter, the field has a much tighter density. Much tighter. So that's the difference between the field and matter, is that somehow this separated field locations have been consolidated. And so this is then again kind of goes back to Einstein, where you can sort of understand that what's creating the Einstein's dimple in space is really the fact that what mass does, what being called matter is really just having a much consolidated, higher density of field. You now have more things, more interactions. So you possess more of these BBs. The BBs are closer together in your matter than they are in the open field. Alright, I think that might be understandable. So that implies a kind of stretching, because there's only a certain amount of BBs in the whole field. So if I consolidate some here, just like with directionality, if I consolidate direction, I had to pull it out of the field somehow. Well, the same thing is true if I'm consolidating distance between interactions, or however you want to describe it, between BBs. The field is now more spaced. So I can't consolidate matter without stretching space. Okay? I can't make matter without stretching space. So the field ends up, the particles and the number of BBs in the field has to be reduced proportionally to how much I consolidate the BBs in the matter. Okay, that's simple enough way to say it. Alright, now to induction. Now induction is important because that gets into this whole magnetism, electricity thing. Induction is a real important word in magnetism and electricity. And it has to do with what's causing a kind of chain reaction. What's causing this this thing that appears to be a powerful force, like magnetism, that comes from nowhere. It's somehow generating all the time, but it's not really generating. It's being created out of motion. So it doesn't exist until the motion exists. So that's where this guy is talking about magnetism and all this motion. But none of this motion, what appears to be action, none of this action is happening until it's induced. So in a sense, nothing has gravity when it's just sitting there, saying, I'm a thing, I exist. Well, I don't have any gravity. I could be the heaviest thing in the universe. I could be the most consolidated thing in the universe. But if I don't have any, if I'm not absorbing any of the field and gaining velocity in some vectors, so if I'm not gaining velocity, I'm not producing gravity. So gravity can only be produced once you initiate the movement that we see we see it as a consequence of gravity, but actually the movement is creating the gravity. It's inducing it. So now we get into spin, and we get into the swirl of the sun, the idea of stuff moving, and how that trips, creates these probabilistic imbalances, and that's the first trigger. So if, in theory, there could be two material objects, and they could be, they have to be now pushed into each other's realm of influence, let's call it. We want to create gravity between them. We want to see gravity happen. So how do we introduce them into each other? Well, one has to sort of move into the other's possible gravitational influence, in the sense that it has a timing thing. It's the speed of light to get back and forth. So the communication is at the speed of light between these two things, in the sense that it's these little quanta moving the speed of light, or the thing that are transmitting the information. Okay, transmitting basically the force that it'll either change something's velocity or not change its velocity. So it has to be enough force to change its velocity. So what's happening though is that, as stated, everything is going through phase changes. So I don't know how exactly to describe that, but at any one moment my arrows, okay, I'm balanced, but at any one moment I can be imbalanced. So at any one moment I could have 3 arrows going this way and 1 arrow going up, or I could have some other arrangement. But in net, I'm going to be balanced in the end. So again, it's at any one moment I could be imbalanced, but in the end I'm going to be balanced. And the trick is that when something's interacting with something else, when it starts to move into its field, it could have some state where it's highly imbalanced. So in that highly imbalanced state, when it's obviously over, like it's got more imbalance than its velocity would justify at that 1 second. So it appears like it's going much faster than it really is, because it hasn't done its reverse yet. So it's got the 3 heads in a row, and so it comes in with the 3 heads in a row. Well, the other body just sees the 3 heads in a row. It's thinking this other thing is gaining acceleration because its speed isn't the same as its arrow disposition. So it's going to be absorbing from the field somehow, but it's just going to be reabsorbing balance that it'll inevitably have to have. So it's just going to, it's not really taking anything, but at this one moment it looks very imbalanced. And so that appearance of velocity or acceleration, because now it's moving faster for this brief second, for this 1 second, it's moving faster than it should. See, it's really only one arrow imbalanced, but at this moment it looks like 3 arrowed imbalanced. So at that moment it looks like it's accelerating, but it's going to be at the next moment it's going to inevitably, the field is going to balance, so the balance is going to take away that acceleration and put the opposite acceleration. But at the one moment it has acceleration, and that's what the other body sees, is that acceleration, so that absorption of arrows. That means less arrows are coming into it, because this thing has just absorbed 3 of them. 3 heads. It just ate 3 heads. So that the 3 tails are now the absence of pressure here. And so now this pressure is stronger. Okay, but there's still, you know, it's balanced, and this is imbalanced. And so now this thing is going to accelerate, which means it's going to absorb these arrows. It's going to absorb some of these arrows, and now it's moving towards the thing, and that absorption means it's going to produce less arrows going this way. So now if it's producing less arrows going this way, it can't counteract this extra arrows in here at this moment. And so now this extra arrow condition becomes a real condition. Now it's actually going to stay. That's going to be its new native position, is this accelerated position, this extra velocity position. So its character exists for a millisecond, you know, one moment in time. And what's really happening is the other body absorbs the counterbalance, the thing that would take that away and say, no, you only do that for 1 second, you don't do that for 3 seconds. So instead it's doing it for 5 seconds. And so now it's gaining acceleration because now its character has been redefined. Its native condition is now redefined because the other body ate the thing that would have balanced its condition. So now its condition is imbalanced. Anyway, so this just keeps happening, this back and forth keeps happening, where as this one gives less to this one gives less to this one gives less to this one gives less to, and so the gravity gets stronger and stronger until it gets up to its whatever you want to call it, its maximum. And the whatever per second, the gravitational force at its location is going to be some amount of meters per second, and that'll just keep changing as it gets closer, of course. So it goes from 9 meters per second, and then it goes to 8 meters per second. I mean 10, and then 12, and then 50 as it gets closer and closer. The two bodies move closer and closer. The acceleration gets more and more intense, and the velocities get more and more high, go higher. So it just grows. It just feeds and feeds and feeds, and it just keeps getting fed until something stops it, till an opposite force is strong enough to say, no, I'm going to restore balance. You're going to stop moving. You're going to stop accelerating. All right. What I want to add to that. So obviously things like spin can cause that too, where like a big body could spin, so its internal structure is rotating or spinning or moving, swirling, and that it can induce gravity because one part of it is actually accelerating. Part of it accelerates as the other part's decelerating, but it's closer to the part that's accelerating, so it has more positive gravity than negative gravity, in a sense, right? I mean, it's further away from the part going away and closer to the part going toward, and by that circumstance it ends up inducing this constant you starve me, I starve you, you starve me, I starve you of induction. So anyway, so the point is that's very, you see that a lot in magnetism. How fast you move something, how fast you move magnetic fields determines how much, how quickly you accelerate the bits, how quickly they go from not being influenced much to being influenced, being starved a lot. And so that's the whole induction process. It's just fast induction is going to be it's going to have an effect that's going to be very different than slow induction. let's see, how else to accelerated induction. So it's when there's already a force applied, a force that's creating the induction in the sense that it's pushing something into induction. Yeah, how else to say that? I can't think of any way to, I can't think of any offhand way to describe that, but you know, because it does get kind of complicated. You know, because it's, I'm just trying to think of, you know, I shouldn't be trying to think of it now, but you know, it's not an oscillation, but I'm just trying to get the idea that, anyway, the point that I'm making is that the induction is a process, and depending on how fast the process happens will affect how much how to say that, how, well, I mean, how dramatic the imbalance between the two objects becomes. How strong the gravity is how fast they get into that condition of being of gaining enough acceleration. And they have to be gaining the acceleration from the field, not from something. Like if I'm pushing something, that's not really the field, right? I haven't taken anything from the field if I'm pushing it. So if I push something at you, it's not the same, because I didn't, the field is still going right through the object and it's still getting to the other thing. So it has to be an acceleration that you induce, but once you induce it, it now absorbs the field from the field, not from any other force but the field. Okay. It's got to block the field to create gravity. It's got to, and blocking the field is really absorbing the field. So this tightly condensed matter, right? So that's where I want to get back to this condensing thing. Ends up being a consolidation of the field, and it ends up, especially when it has a velocity, it'll have a completely disproportional amount of the field. It'll have a bunch of stuff going in the direction of the velocity. So it'll possess a huge imbalance of field. Yeah, so it becomes a force carrier, if that term can be used. But force carrier just means imbalance carrier. It just means that you have more stuff going in the direction of your force. You possess more arrows. And for you to possess them means that something else can't. I guess that's the key thing here to this whole conservation principle. If you have absorbed, if this consolidated space now has a velocity and has absorbed a bunch of direction in this direction, the field outside of this thing, in net, this field out here, has to be minus this. So there has to be a reciprocal absence of that field somewhere. So somewhere in this external field, there's something that has a consolidation of these opposite arrows. Somewhere they're loose in the field, or else they're in some other matter that has exactly the opposite velocity. So everything's conserved in the end, and all you're really doing is pulling, not pulling, wrong word, trapping directionality. So anyway, so yeah, I have to get to the how. You know, there's the mechanics of it. Again, is pretty simple. It's just this idea that you know, this opposite balance idea, that if you create a shape and you're allowed for this to go kind of crookedy, okay, and then it's still going to find its place again. So even though over time things go wobbly and go way out and go distorted, in net they're always going to end up in this box. They can't escape the box. So no matter where they go, they're going to be somewhere inside the box before probabilistic rules. You know, like you can only have so many heads in a row, and there's going to be some rule that says you can't go more than that. You can't go more deviant than that, and you're going to end up back into this configuration. So you're not allowed to escape. The density of the matter is high enough to overwhelm the eccentricities of the chaos. So it's like density beats chaos. So as you get more dense, more consolidated, you take away more room for chaos to allow disruption or breaking. And the pattern will remain, even though the pattern will be eccentric, it'll still stay within that box. It'll just never be able to get outside the box without the equalizing force equalizing it back into the shape that it was originally. So it'll always get forced back into that condition. I don't know if you got that either, but that's how the imbalance starts. Because once you create that durable orbit, no matter what I'm calling it, it's an orbit, but it's not really just a. It's really just it's really just a collection of location, or a collection of these BBs, and you know, in a sense they're orbiting, but in a sense they're not. You know, I don't know how to say this. I mean, it's not strictly an orbit because it can be in any direction at any one moment. So it can be going backwards or forward or in or out. It doesn't. So it's not really an orbit. It's a location having an orientation. And so the locations will have very bizarre orientations over time. But the net effect is that there's going to be a certain amount going this way and a certain amount going that way. And like I said, if you expand those numbers big enough, like 500 arrows going in each direction, you can understand that all you need is 499 and 501 to end up having a velocity. So if I have 500 arrows, 501 arrows going this way, and 499 going that way, as part of my matter could have a velocity that would end up being 10 miles an hour over time. Net. Alright, and the time thing is, I'm pretty confident on this one now, too. Well, confident's the wrong word. I'm playing with it in a, yes, this seems to make sense way. That, you know, the one interaction where, you know, the one pure kinetic interaction where two things come in, two things leave, you know, and this really did this and this really did that, you know, it wasn't invisible. That interaction doesn't take, or takes much less time than the head-on collision interaction, which is really a complete U-turn. Okay, so this interaction kinetically, two things come in, two things leave, but what's really happening is this one's stopping and then changing direction entirely, this one's stopping and changing direction entirely, 180 degrees. That this interaction, the head-on collision, is the one that takes time, and that's the one that really creates what we call time. And time is just a manifestation of the density of the field, the number of interactions. So as light travels through empty space, the field is cleaner, less interactions, so it moves very fast because there's less head-on collisions. And then in matter, the number of head-on collisions is much higher because the number of interactions is much higher, so the light moves through the matter slower. I think that's good enough. Alright. So, yeah, that's enough of a video, I think. So I think there's ground. I mean, I've only gotten through 10% of this book he wrote, but I'm getting to the part where he's starting to do all this centripetal, you know, all the kind of big word kind of descriptions, which I think just I think it really degrades his explanation. I mean, you can't really talk that you've uncovered the missing secrets of magnetism when you're still using words that doesn't make it understandable at all. I mean, what do you mean? This is the outside's going clockwise and the inside's going counterclockwise, and it's because the counterclockwise on the opposite end is going into the clockwise on the other. I mean, I think you gotta, and you're saying, what is doing all that? What? How, what? I mean, it's just sort of annoying because these people talk like they've done something to add clarity or unify, and they still aren't explaining mechanism. They're just saying the magic tells this other thing what to do. This magically influences that, or this magically move. What is magically? What's moving? What is? What's the mechanism? So without a mechanism, I don't think you have anything. So that's where I think I have fixed the problem, just by adding the mechanism. It's a kinetic field of direction. It's in motion. The universe is in motion. The universe, every little bit of it is energy. And some of the energy you see, some of the energy is in a configuration you can recognize, your matter will be affected by, and some of it doesn't affect it at all because it's balanced. It's only the imbalances that can affect anything, and they can only affect something if they're imbalanced in a way that is, what's the right word, visible, tangible, that can affect it. It has to be in a vector. It's like if you take that three-dimensional example, you might, if you're at a certain orientation, you're only going to be able to be affected by forces in 2 dimensions. So if you're a solar system, you're only going to be affected by things moving in the 2 dimensions. The 3rd dimension won't be able to affect you as much. Something like that, anyway. It's probably not the perfect example, but it's there to be had. Anyway, so enough of the video. Till next time. So yeah, I'm still working on. I mean, clearly this gives me a mechanism where I can say, okay, the quanta has an energy 1, and I can start adding up these energies and just say velocity is just the acquisition of quanta. I can quantize mass to velocity and say, yes, that's force. So it's completely consistent with Newton and all these people that did all that math. Doesn't change any of that math, but it does give it turns into a real component, and for the purpose of the explanation of magnetism, my argument is just going to be that that's where you get into polarization. So that's where this orientation of movement is important, and spin and all the other stuff was also important. But anyway, yeah, so I'll get to that. Yeah. Yeah, that's enough. I mean, this was supposed to be more about induction, because that's what leads to the magnetism thing, but, you get what you get. If you got something out of it, good. If not, we'll try again next time. Anyway, till next time.